Right, good morning, everyone. Thank you for coming. Could you put your headsets on? Because you'll need it to hear what we're talking about. So, and then we'll make a start. So I think we're all good. Well, thank you very much for coming. This is a bit of an amalgamation of things, and I'm delighted to be joined by some eminent people, and we have some also in the audience as well. But this is very much an interactive session. You know, I do want people to ask questions because it's not often we have such learned company at these events. So we'll keep the Q&As to the end. So just make a note. But we've left plenty of time to discuss all sorts of electrical things. Now, in terms of the session, what I'm going to do is I'm going to introduce Mark Coles in a sec. And Mark is head of technical regulations for the IET, so he's responsible for the IET's output in terms of standards. And Gary is the associate editor, and he's responsible for proofreading and checking and sits on all the committees as well. And collectively, we also sit on the international standards committees. And so Gary's going to give us a little bit of an update about how the updates, forthcoming updates to the wiring regulations happen and how you can comment. And Mark's going to give us a quick potted précis of what's coming up, or what's available now, actually, for people to look at. And I'm going to give a potted overview of the updates to my temporary power book, which is being due for release in hopefully a couple of months, nearly at the end now. So but I'm delighted to welcome also, we have Norwegian representation from standards, and we also have German as well. So you are in very good company today, so thank you all for coming. It's much appreciated. Now, in terms of the temporary power book, there's been quite a few changes since the book was written in 2012. A lot of it is updates to BS 7671. BS 7909 is now on its 2024 Amendment 1 version. And if you bought the amendment, the 2023 version, it's only a one-page annex that is in the amendment. So, but a lot of the information in that was changed, and the book is built on a lot of the work done around generators and similar bits in the practitioner's guide, which is the sort of on-site handbook one. And I'll come on to some of that in a minute. So, like I say, general updates arising from changes to 7909. There's more clarity for event users on the application of things like arc fault detection devices and SPDs and RCD selectivity and use. And also supply resilience planning as well, which is quite key to what we do, is making sure that the lights don't go out and we've got safety systems in operation, whether for evacuations and similar. Quite a big update is the PLASA lightning guidance. Now, this was written a few years ago, and it was to recognise the fact that there's no guidance in the UK up until that point on how to manage lightning at events. And the BS 7909 did a bit of a body swerve on this originally and just referred people to the British standards for lightning protection, which weren't really suited. So the industry guidance now recognises how to manage those types of events, and the updates on the book look at the electrical aspects of what you might need to consider in terms of planning for that lightning events. Generator operation is a new section, so this is widely expanded, and I've looked at generator stability, which is becoming an increasing issue now with switch mode power supplies, which are found in pretty much most things, which can lead to instability of the generator. You know, the current ways of getting around that really is to just add load banks on, which is not the most efficient. So the use of the use of battery storage and similar is also coming to the fore. So a bit of content around droop control, parallel operation and protection, what to consider when designing systems to operate in parallel. Battery storage systems, they are classed as generators, and I've worked for a few clients of late when I say, do you use generators? And they say, no. And then you're walking around the warehouse and you see there's little Instagrids on the shelf and smaller inverter-based systems. They are actually classed as generators and need to be treated as such from an electrical standards point of view. So there's more commentary on that, in particular the fault modes, because one of the challenges with battery storage units is knowing what will happen if someone actually drops a crowbar across the output, because generally the electronics doesn't have the ability to deliver the fault currents required to operate protection. So usually the electronics will shut the system down within an allotted time. So it's important to get from the manufacturer how that will work and what happens when you have these systems paralleled up in operation. Hybrid modes are also discussed as well. Common now with stage 5 generators, where you have issues with the needing to keep the engine working hard so that it remains hot, because otherwise the exhausts clog up with the urea from the AdBlue. So again, running generators on low load, and particularly in parallel, is not really a model we can sustain anymore with the modern engines. So battery storage is becoming quite common in hybrid mode to actually power the loads, and then the generators are used to charge the batteries. The generator earth electrodes and protection, again, this builds on work that's been done at the practitioner's guide, and the relationship between the generator earth electrode values and the protection on the output has been explained, and so one can ascertain what earth electrode values you need compared to the protection you have on the output, and how the two are related between them. Again, examples of fault modes, and classics are a bad earth electrode, and then you have an insulation failure on a cable making the ground live. So things like that are explained, and the symptoms that you can depicted in the pictures in the book to help people understand and reinforce that relationship between the earth electrodes and the protection. The testing of electrodes, there's the classic three-pole method where you put in your current probe and your voltage probe and check the electrode under test. There's some rough and ready methods you can use by using parallel or two electrodes and a continuity test of things to make it more accessible and easier to do in the field. They're included in the guide as well. Because the electrode testing equipment is not always available to everyone. Protective bonding, nothing really new. There's no changes to this from a standards perspective, but what I have done is provided more clarity on what is an extraneous conductive part, what needs bonding and what doesn't. Again, lots of things from cable bridges to Harris fencing, you see green and yellow wires strapped to it, which shouldn't have them at all. And there's a particular need to make sure that you don't actually introduce faults where faults don't need to be, and people have been injured by being in contact with random bits of metalwork that someone's earthed, which it shouldn't have been, or bonded, I should say. So there's more guidance on that, and also electrical environments. So if we've got generators outside, for example, running supplies into the building, we need to create that eco-potential zone. So how do you go about joining the two together? And there's more of an explanation on that. And mobile and transportable units, again, this was quite a short section in the first book, but I've added a lot more content now to look at the transformer-based systems and how the benefits they can provide in broadcast vehicles and similar bits, and also some of the internal wiring requirements of just bog standard units that are not related to broadcast requirements. And I think that is about it. So yes, I'll now hand over to Mark, who will give us a whistle-stop tour through the updates to, or Amendment 4 of BS7671.
That was an early trip there. Morning, everybody. Thanks for coming. Thanks for sticking with us, and I hope you stick with me through this. I'm from a hardwired background, if you like, and I'm not that au fait in particular with what happens in your industry. James mentioned BS7909 earlier, and when I first got involved in this side of things 20 years ago, there's four of us, we sat in a room together. James was Mike Lefebvre, Dave Roberts, and myself, and I was bringing more the conventional, if you like, hardwired side of things into your industry. And I remember some drafts that James had put forward, and it was things like, you go to site and you do a recce. And I said, James, recce isn't standard speak. And then it was supplies out to the cabins for the talent. James, talent isn't standard speak. So that's what I was up against, and I tried to bring a more sensible approach, if you like, if you bear with me on that one.
We wore him down in the end.
You wore me down indeed. And there's a lot of belief that BS7671 doesn't apply to your industry. But when you look at the scope of BS7671, it's the connection of electrical equipment to form an installation, and from that point of view, it does cover your industry. The belief is it's plug and play, and it's in the back of a van to a warehouse. It's out then across Europe. It's not tested like a conventional electrical installation, but nevertheless there's still requirements to make sure you're on top of what's going on. So what I've done is I've tried to pull out what I believe are salient points that would affect you in your work, in your industry. So please bear with me if I don't get it quite right. Do I move down here? There we are. So the first thing to point out is the document is out, it's a draft for public consultation, and it went live the 7th of August. The closing date is the 3rd of November. So if you follow that link there, you go to that takes you to the IET's website, which ultimately puts you through to the BSI's website, where you can log in and put your comments on the draft. You can see the drafts, and you can put your comments in on there. Don't just go in and say, this is a load of rubbish, I think it's crap. Put in a proposal, because the proposal then means that the committee has something to get its teeth into and possibly sees things from a different point of view. So please go in and do that. So that's that point there. The next thing is to bring out salient points that might affect your industry. Chapter 42 here is in part 4 of the standard. In part 4, the principles. Part 5 is about how to do it, the equipment you'll need, but part 4 is the principles. This one on the screen here is protection against thermal effects. This is fire escapes. And it might be, for instance, in a building like this, or you might be out at an event, and you've got to get cables from a truck outside into the building. But you need to bring the cables through areas that might be escape routes. So it's a discussion with the building owner, whoever's given you the work, to establish what are escape routes and what you need to do in that area. Would you have anything to add at this point about escape routes, fire escape routes?
No, but it is common to run cables through, through stairwells and things like that. So it's just about making sure that you have that conversation with them about whether it's a protected route, what measures might need to be done, and your risk assessment would reflect how long you're going to be there, and how long the show's running for, and what other controls might be put in place. But
Part 5 of BS 7671 talks about protected escape routes, and these are the stark kind of staircases you see in football stadiums, for example. It's a concrete staircase, there's a handrail, there might be treads on the edge of the steps, there might be a light, fire alarm system, but that's it, there's nothing else going on in there. So places like that, the owner of the building will not give permission to run cables through there. If that's the only route, then you need to put provisions in to ensure that it maintains that protected status as a protected escape route. But again, that's another part of BS 7671, but it does feed into this as fire escape routes. So that's something to consider. Next thing I want to look at is ferromagnetic enclosures. So you'll be familiar that where you have cables going into a ferrous enclosure, and if they don't go through the same window or the same opening, you can get eddy currents flowing, which can lead to overheating. Well, what's gone into BS 7671 this time, it says if you're up to 200 amps, there's not really a lot to worry about. If you're going over 200 amps and you're going in through different windows of entry, then it's a discussion with the owner of the manufacturer of the equipment to make sure that they're happy with the heating effects that could occur when you're over 200 amps. But we were having a chat about this really. It's something that, as you can see on there, it's something that you don't tend to bother about in your industry.
No, I know, and many people would have noticed 400 amp power lock connectors, steel panels, and it's never been an issue. And I think largely the reason for that is because it is a balanced system. You've got, pardon me, 3 lives neutral and any leakage currents on the protective conductor, all completely balanced in that one panel. So I've never come across these things warming up in use or being an issue, and I'll be interested to know if anyone else has it.
But what's gone in here, this is deemed to be a bit of a relaxation. So it isn't all bad news, you see. We're making it easier for you out there. So next thing to look at is premature collapse. So this is what happened here was where there were 2 incidents in the UK where firefighters had gone into a building, and because of that, I keep looking for examples in buildings, because of the way that cables have been lashed up using nylon cable ties, with the heat of the fire, not particularly the flames, but the heat of the fire wafting down a corridor has melted the method of holding the cables up. The cables came down, and a number of firefighters lost their lives because of their breathing apparatus got caught up in the cables. So what came in here was to avoid premature collapse in areas like that where cables are routed across doorways, for example, that need to be held up by metallic ties or some form of strong mechanical construction that would stop premature collapse. So that's something to consider where cables are being run in and out of buildings and across door openings and stairwells, that kind of thing. So that's something that's gone in there. But one of the points here, this requirement it's not about maintaining the integrity of the circuit. This part is purely about ensuring that the cables don't fall, and where people need to get out of the building or firefighters need to come in to evaluate what's going on inside. It's about stopping that premature collapse. If the circuits are meant to be there for the longevity, to see the building through the fire, so to speak, then that's something else to consider. But that's what's gone in there. This requirement's about premature collapse, and it's not about the integrity of the circuit, although that's something else. Next thing to look at is selectivity between RCDs. This requirement, again, this is where you've got the upstream device is a time-delayed RCD. The downstream device is not time-delayed. So you've got RCDs in series. Now, what this is saying is the downstream device, that should operate first, but when it does, that device needs to be a multi-pole device to switch all live conductors. And by live conductors, it means the phases, or the lines, and the neutral conductor too. Because if you draw the circuit diagram out, if the downstream device, if you're just switching the line conductor, then depending where the fault occurs, you can get currents flowing, and therefore you haven't removed the fault. So the downstream device in this instance needs to be a multi-pole device. What we got next? Firefighter switching and isolation switching, chapter 53, section 537. This is where, conventionally, you've seen these things in buildings where you've got, could be a shop, for example, could be a burger, kebab shop, that kind of thing, where you've got neon signage on the outside. And there's been a requirement that you have a firefighter switch on the outside. What's gone on here is that where you've got neon signs, for example, operating above 1,000 volts and you need that switch, what's been added in C and D here, that the person from the fire brigade, from the fire authority, might say that because you've got battery storage within the building, for example, that's another risk. Therefore, we want you to have a firefighter switch going on for that building. Now, with you coming in on a temporary basis, bringing cables into a building, it might be a discussion with the fire authority, with the person in charge of the building, that because you're bringing in battery storage, for example, as an alternative source, it might mean that they've got to alter their plans, or you've got to do something and install a firefighter switch under certain conditions. Anything to add about that? No? Good. I like when there's no questions or things brought out. That was that one. I've gone the wrong way, haven't I? It's slick, isn't it? Come on. There we are. That was that one. Come on. There we are. This is something else that's going on in your area, I feel. This is power over Ethernet. So this is up to 60 volts, DC, ELV as we call it. And this is where power, it could be power for speakers, it could be power for lighting, but requirements have gone into BS, going into BS 7671 about installations in these areas, which we see more and more of. Again, I'm looking at you for examples here in your industry from, is it LED lighting?
Yeah, so as you know, in installation, some small LED downlighters and things like that now PoE powered, so you've got your data and your supply over a Cat5. You can get PoE powered speakers and things, but also, you know, just on events, if you're running PoE up to power your switches and things like that in a rig, then this section technically applies. And it's a lot of the content is around the type of supplies being used, and that will really come down to the PoE hubs that you're using to generate the PoE. And I expect most of them will be compliant, but it's certainly worth having a read. The special location also refers people to the telecoms installation standards for the cable management, because with high data rates and things like that now, there's particular requirements about things like how tight the bend radii should be for the cables and how you should strap them down. Not, you know, doing it tight with a nylon tie, but doing Velcro ties and things like that. But that's a completely different standard to this. This is more about the sort of the fire risk from PoE, because even at 90 watts or whatever, that can still start a fire if the cables get damaged. So that's as I recall, is the prime reason for the introduction of this section.
Yeah, so essentially this is looking at the source of supply, so there's BSEN numbers for the type of supply the power supply you need for the equipment. But also, as James pointed out, there are heating effects to consider when you've got all those cables bunched together running in all directions. Okay. So what we got next? This is one of the last points I want to bring out. This is a change to Appendix 4. Appendix 4 is about the current carrying capacities of cables and volt drop, that kind of thing. And what's being added is if you've got cable in ducts, the permitted currents for cables in ducts are different to other types of installations, like to buried cables, for example. I very much doubt you do buried cables. Do we see this a lot in your industry? No?
Not really, no. You might dig a slit trench to run cables across the ground on a festival or something, but we don't really get involved in that. And it's mostly armoured cable, isn't it, that part? So if you do installations, permanent installations, then it's worth being aware of. But for the most part, for temporary, it's not a particular item of note, really.
Yeah. It's just really for information. And then there's Appendix 15's gone in about escape routes and fire protection in those areas, which links to what we said earlier about the protected escape routes. This is essentially the appendices are there for guidance. They're informative, not normative. That's just for your attention. On to generating sets. This is an interesting one because the arrows there are indicating that we're now talking about bidirectional devices. So conventionally, think about it. You've got you might have a utility supply into a building, and then you might have a battery storage, or you might have a generator that's then contributing to the system. It's operating in parallel. Well, you've got sources, you've got not current flow, it's more about the energy flowing in different directions, but you've got sources essentially on both sides of protected devices. And there was one death in Australia because what happens is when the source is on the wrong side, if you like, of a unidirectional device, let's say an RCD, and the RCD is operated, then the source that can burn out the innards of the RCD, the coil and the control equipment within. And when you reset, you think it's reset and it's working again, well, the device quite often has been fried and is no longer operable and will not save a person's life. So what's being said here is that the device has got to be bidirectional. It's got to be suitable for a source that can go on both sides of that device. It's all about the labeling. You know, we've got the load and the supply end. Conventionally, that's what we see. The bidirectional devices either are not identified, so you can connect any source on either side, or you've got the markings to show that is bidirectional. So it's important that where you've got multiple sources of supply, that the devices you use are bidirectional. So that's an important thing that's come along. Also, what's come along is that where, I don't suppose it would affect you that much, really, but where you've got more than one source of supply and you're bringing in that second supply into a distribution circuit, currently under BS 7671, it's permitted to have other loads on that circuit. What's being said here is the proposal is that we should not have any other loads on that circuit. We should just have that dedicated source on that distribution circuit. What we're seeing in Europe is that people can buy what they call balcony PV. So you buy a balcony from the likes of B&Q or similar, you hang it on the balcony and you plug it into a socket. So you're paralleling up with what's going on. And in theory, you're going to use the supply from the balcony PV. But think about it, you might have an extension lead and you buy four of these and you can plug them all in, daisy chain them all together, and you've got the risk of overloading. And then that's also on an existing circuit where you've got loads, so it's a real headache waiting to happen. So that's what's happened here, that it's been split up, and the requirement here is saying you shall not use a generator on a circuit where there's other sources going on. So that's an important thing. What else have we got to talk about? A new section, a new chapter on battery storage, stationary secondary batteries, which has come in from a basic document at IEC level, and we've tweaked it for our needs within the country. So that's gone in. But what's highlighted here is we're not talking about batteries within the likes of fire alarm panels or batteries in equipment. It is about the storage battery that you're using to supplement your supply within the building. And it might be through an inverter, of course, but this is the new chapter that's gone in. It's very interesting, we believe it is. And I'm running out of time. This is just to highlight that what's current in the UK. We've got the Brown Book, BS 7671 from 2022. We had an amendment this year on bidirectional devices, put the two together, and that's what we're working to currently, and there's a QR code to take you to that particular part of the IET's website. And one other thing we're doing at the moment, the IET, we're doing research on neutral current diversion. And what happens here is where you've got a supply out from the street, and if the supply out in the street has been damaged by corrosion, water's got into joints in the street, or it might be roadworks that has dug up part of the cable and has severed that PEN conductor on the PME supply. So you've lost the connection to protective earth, you've lost the neutral. And what happens is, because of the bonding arrangements we have in buildings, and we've got pipe work, water pipes, gas pipes, which are running down the street and they're going into all the buildings down the street, there is an electrical connection from this building to that connection through the pipe work, and it's bonded. And what happens is, when you've lost the connection to neutral out in the street, the neutral then finds, the little current finds its way through the pipe work and ultimately back to the transformer through earth or through other pipe work. Now, the way to find this, there's a way, IET's got some guidance out on this in Guidance Note 3. But before you do anything on site, before you take a measurement of ZE, for example, the measurement of ZE is taken by disconnecting the earthing conductor, you're meant to check for neutral current diversion. So if there's currents in the order of amps flowing through the earthing conductor or through the bonding, we want you to inform us about that problem. And this is the way to do it.
Yeah, so if you're a venue
okay,
owner, that's
and I'm running
that's
out of time, aren't I? So there we are. That's my bit. So thank you for bearing with me.
You're up. It's your turn.
I'll hand over to Gary now.
Thank you, gentlemen. Good morning, ladies and gentlemen. How are you? That's good. Right, my job today is to tell you why these changes come about and how they do. Does anybody of you have a qualification in an electrical subject at all? This is excellent news, right? This is all about why we have these changes. You've seen over the years, and Mark's even introduced this subject, that things are changing. So we seem to think that we like to be able to stand on our own 2 feet, but things are coming fast, and we need to accommodate these and make things happen for you. Right? It's not just one organisation that makes these changes. You know, things happen all around the world, and I've seen some of the products that you've got available in your show today. There's lots of products that have become available, and the manufacturers work with standardisation. So we make things happen internationally and then in Europe, and it comes down to us. So this organisation called IEC, International Electrotechnical Commission, was formed in 1906, and they started looking at things like just vocabulary and terminology and the measurement, the units of volts, because even in the countries themselves, they had different interpretations of these wordings, let alone from country to country. So we needed to standardise on this thing, right? And there's about 89 countries there, 62 of which have voting rights, and they start from like Australia, Brazil, Canada and China, right up to the United Kingdom, United States of America, and I think the last one on the list is Vietnam. You're pleased to see that the UK has been a founding member since 1906, so we've been actively involved in standards internationally for well over 100 years. Now, when that all came about, that was great, but in Europe, in the 1970s, about 1973, an organisation called Senilec came together, and they took on board most of this stuff, and basically, sometimes they repeat some of this and sort of take on board the IEC standard, but make further requirements for us, really to help improve on trade, right? So basically freedom of trade, so we could sell products to, you know, the continent and back to and from. So we reduce costs and aided that. If they do mirror an IEC standard, what that means is that you can take that and further improve it and sell it around the world, which is all good stuff. And then once these standards come down from BSEN standards, they come down to our national committee, JPL 64, which I'm going to tell you about now. So basically, these standards are formed internationally. So IEC 60364 is the standard. Then it comes down to Europe, which is the HD. So we work for the documents there. There's a lot of documents inside the 7671. If you've ever taken the trouble to read in there, they're individual. So I know that we moan about this, right, about having to buy a new book every few years, but crikey, I'll tell you, it's a lot cheaper than if you bought these standards individually. So anybody that works in different countries there, you have to buy them separately. We're doing all right in the UK. Now, if you comply with the standard here, you are likely to qualify and meet the requirements of legislation, the electricity work regulations. So that's important there. And also we get involved with other documents for industry, for guidance and bits and pieces, which I'll tell you about in a second. How does it all work? Well, obviously when it comes down from the international standard, it comes through to Senilec, and then in the UK we have JPL 64, which is the national committee, the IET, and BSI, you know, it's a joint publication, so that's what J stands for, joint. P is for power, and EL is for electrical. So this is why we have the JPL 64, and it's made up of a large number of organisations, but all of the work, technically, is split into 4 subcommittees, A, B, C, and D. So when we talk about A, we're talking about testing, verification, part 1 for systems and definitions and things like that. Eade focuses on wiring, and I know that James was talking to you about that, and sort of technical capabilities of cable and current carrying capacity for the fire systems and loadings and like that. C covers electric shock and a few other things, and D fills in all the gaps as well like that. It's very, very comprehensive work, and about sometimes 10 to sort of 25 organisations contribute to that work. Okay, so they've got all the experts wherever we can in those areas. And then when it goes to JPL 64, they're like the rubber stamping exercise. We take on board what's been suggested, and we make sure that's implemented and then rolled out. All of this takes a considerable amount of time, input, review, careful consideration, considers standardisation to accommodate new technology, best practices, and obviously harmonisation with other matter from around the world. And as Mark's already alluded to, that we've now just released an Amendment 3, very short publications available for free, so we're not all taking the money, right? We make it important for you to have that information. And we're already rolling out now a fourth amendment, right? And one of the things that comes up is like, what's in it? What are we covering? But the subject that kept being asked of me is, what colour is the book? Right, now I've done a multicoloured picture there for you, but something that was touched on with functional bonding conductors was pink. I can't ever see it being a pink book, but you know, please put in your comments and we'll see what comes up. Okay? Now, that is remind you there that comments are open till the 3rd of November. I do want to stress to you that every comment is read, every comment is considered, every comment is debated. Even if you think that you're not understanding it, somebody in that room will go, I think this person is getting at this point. Because sometimes you see it in a different way. Please pitch it in there and we will endeavour to get it right for you. Right, if you want further information and you can't understand the wiring regulations, there's a plethora of guidance from the IET there. We do some guidance notes. Okay, I'm not sure if you're familiar with these. They're available in publications as a book form. But if you're very much a digital techie person, they now do some electronic versions. Okay, they do them in bronze, silver and gold package. I think they do like a gold plus Eve as well. So the basic package is the wiring regulations, the on-site guide, guidance note 1 for selection and erection of equipment, and guidance note 3 for inspection and testing. But as you move up there, they get more and more comprehensive, and I think the Gold Suite even includes James's new book. So there you go. I mean, you can't get better than that, can you? Right, if you want sort of time to digest it and see how things come together, there's some written material. There used to be a publication called Wiring Matters, very detailed subjects on generators, sort of outside wiring systems and lots of other bits and pieces, because there's too many to mention, as you can see, right? It used to be a publication, but now it's all online, and lots of people contribute to that, and I think they're very, very informative, and I think it'd be wise just to dip in and out. I used to just cut them out and say the subjects are relevant to me. There's obviously lots to cover. If you like the personal touch, Mark's team offer a technical helpline on Mondays and Fridays, Mark, yep. Okay, so if you know, but do read the website in case there's any holidays, especially on public holidays, because they're entitled to some time off. And if you like just to digest and ask questions, I've got to tell you there's an IET NGX forum. It's an amazing resource, and you can reach out to some very skilled and specific people. You know, our colleagues even answer questions at 2 o'clock in the morning. I don't know how they do it, but we get there. And that's it. Thank you very much for putting up with us. It's been a pleasure to meet you. Thank you.
And now it's up to you. So, Gary, do you want to grab some headphones on the thing? So does anyone have any questions on that at all? Any other burning technical issues? Oh, down the front. Sorry, you'll have to wait for the mic because we can't hear what you're going to say. So,
what are you saying? I can't hear him.
Hello.
Hello, we can hear that.
Yeah. I just wanted to ask a question about the multi-pole RCD thing. We make a number of distribution boards, and a lot of the requirements in the UK, people use single module RCBOs, and obviously they got a solid neutral in them. I take it that once that comes along, those solid neutral things are out the window.
That's what it's looking like. But if it's not going to work for you, you need to put a comment in.
Yeah.
Well, yeah, the thing is that there are other devices available. They just save space, but once you've saved the space, obviously you've got things closer together, and all that heat rise you talk about then happens. So it might be a good thing, to be honest with you, rather than a bad thing. So
That's interesting.
Yeah. Okay, so
Still do put a comment in, please, because it just gets us thinking.
okay, yeah, we'll do, no problem.
Okay, good question.
I think
thank you.
the other aspect to that is to make sure that you note the financial impact on the industry of having to upgrade all of the equipment, which is obviously a challenge, because every time an installation's put out, it's classed as a new install, it has to comply with the current edition, etc. So so it's definitely worth highlighting that. Just quickly, one on commenting on the standards as well. It really helps to offer an alternative. So on the commenting forms, it says, which bit are you commenting on? What's your issue with it? What's your proposed change? If you don't put anything in the proposed change, a lot of the time people say, well, we don't really understand the question. They haven't given an alternative, so we'll just note it and move on. So it's quite important to make a proposal or put some context around what you're looking at. Thank you for that.
Can I add to that? The gentleman at the front was saying about his particular situation, and what I've established is that when people would say, this is not going to work for us, we have nothing to go on. We can't elaborate that and sort of reach into your mind, so you do need to sort of substantiate that.
Any more for any more?
Must be. Oh, gentleman over there. Or lady.
Hello.
Hello.
The Power over Ethernet changes, would they include other power and data kind of... I'm thinking specifically kind of triacs for cameras.
No, it is just PoE, he says bravely. I'd have to check the scope of that. But yeah, no, it's definitely aimed at PoE because it's the new technology coming in that's going to be present in a lot of places. It wouldn't affect triacs. But I'll double check. We have the draft here, so we can have a look afterwards.
Are we talking about a piece of equipment here?
No, if you imagine you got your OB truck outside, you run your or in a studio camera control unit in a studio, and you run your triacs, which has got your power data and everything to the camera. So that's not in the scope of 716, is it?
Thinking, continued with the theme of PoE, is there likely to be any change on the requirement for physical separation between mains cabling and data cabling, if that data cabling is actually running PoE?
Segregation.
Because that's a real pain in terms of installation at the moment.
Well, the current requirement is to separate band 1 and band 2 circuits unless the wiring method is insulated for the highest voltage present. That's how it's worded. So nothing is changing from that point of view.
Okay.
At the moment.
Right.
Yeah, there is requirements in section 444, I think, for segregation. But again, I'd have to check that. But no, there's no proposed changes on that front. This is going to be a quick win.
Yeah.
Hello there. We have an incredible collection of festivals happening in the UK, and we have global warming. But when we think about cable ratings, we tend to think about like 20 degrees ambient temperature and things like that. But out in the sun, blimey, it kind of get hot out there. We think, even on a hot day, the measurements we hear from the Met Office are actually, a shaded thermometer. But our black cables are out there maybe getting up to 50 degrees. At what point should we be seriously considering derating everything?
Well, the current carrying capacity tables in Appendix 4 are all based on an ambient temperature of 30 degrees. So for the black cables or black distros or anything like that, as a rule of thumb, you add 10 degrees to the ambient to take into account the solar gain. So if it's 25 degrees and you're out in the sun, then you add 10 degrees, which brings it up to 35. And so you just apply the correction factors given in the appendix to the current carrying capacity of the cable. So that's something you'd have to do as a bit of a fact packet exercise before you get there. But you won't know what the actual loads are on the cables and what the current is actually in that circuit until it's all up and running. So there's always going to be an element of estimation around it. but that's the way to deal with it, is to take the current carrying capacity from Appendix 4 at 30 degrees, add a factor for solar gain, and deal with it accordingly. This also applies to black distros as well to some degree, because when you've got a black rubber box type of distro, the internal temperature can get quite hot.
Yeah, that's it. They're completely enclosed and until you find they're filled with water, which won't come out. Yeah,
that's very true. And so it's always worth making sure that those are protected against that solar gain as well. So I've nicked catering tin foil from the catering before now to try and keep the sun off distros, but it's not the most orthodox of methods, shall we say.
Okay.
It is the expected external influences, isn't it? You've got to take that into account with the design.
Have a rule of thumb? You know, when you stand there, because the guys aren't going to have the tables with them, so could they sort of knock off 20%? Is there like a...
Yeah, that wouldn't be a bad number.
So does the cable come with a rating, and then you can sort of say if it goes above 30?
Well, it's dictated by the connector size usually. So you'd have 32 amp plug and socket on a 6mm cable.
Yeah, then
so,
if these guys are out in the hot sun, you know, in Glastonbury or something, then they basically could just do 10 or 20% and feel comfortable. It's a rule of thumb, but it would be there on the side of caution.
Yeah, absolutely.
Just a general question on multiple supplies, because a lot of festivals now are running on very large battery installations.
Yeah, massive attack with solely batteries.
Yeah. Are we just dealing with them in the same, reg-wise, in the same deal as a generator, in the sense of protection, RCD, selection, and so forth?
Yes, and they are generators in that respect. It's worth noting that there's work at an international level on generators as a supply. So what's in Section 551 at the moment may change in the future, and so the general requirements, they will stay the same. It's a source of energy, it has to be protected against. But what we when you have a diesel generator, you know, if you stick a crowbar across the output, you generally can develop enough current to operate the protection. But with a battery storage unit, they don't work in the same way, because the control systems will just shut the inverter down. So it's about understanding how that works and having that conversation with the manufacturer. And on the smaller ones as well, you know, particularly the smaller, I use Instagrid as a generic example, but some of them have got like a centre tapped earthing arrangement, so you get between the protective conductor and each line conductor is 115 volts. So the RCDs and things like that will still work normally, but some actually don't have. They are just floating systems that have a equivalent to electrical separation as a method of protection. So it's always worth, on the smaller ones, understanding that, but on the larger ones, yeah, it's understanding how they will operate, particularly in parallel in the protection systems.
Question about the cables and cable tables, derating and all that kind of stuff. On the other side of the canal, there's people are actually thinking about aluminum cables for making the life of stations easier by not having to haul that much copper around, just a weight consideration. Is that something in your standard as well?
So BS 7671 doesn't consider aluminium conductors beneath 16 mil because it's the temperature, is the expansion contraction of the aluminium when it's in the terminal. So there's no planned changes from what's there currently.
Are you thinking of sort of BAC power lock type?
125 amp Seacon cables, those kind of heavy. Big.
Yeah, I've not seen that in aluminium. I don't think we've got any tables for that, have we?
They are at the back. We do a whole section on copper, and then afterwards it's aluminium, but I'm not sure they do your type of cables.
Yeah, but thermosetting.
It's an area that I don't look at, but if we can look up now after this session's finished.
Yeah, but it's not common, certainly that I'm aware of,
yet,
unless anyone else has come across it. But
they wouldn't be flexible cables. They're solid cores, the aluminium.
Yeah, that's true.
Except when we go up to on power locks and things, you get aluminium cables or BACs, but they're stranded and obviously much larger cross-section areas, but yeah.
It's not as malleable as copper, is it?
No. And the terminations are challenging in the connectors as well, which is the other issue. Although I noticed some of the manufacturers have done power lock bimetallic connections, so that you can actually connect aluminium onto the power lock connector. Are we running out of time? We are. Any? We have. Any other questions? No. We'll call it a day, but we'll be loitering outside anyway, so look some of these bits up. But thank you very much for coming.
Thank you very much for joining us.
It was interesting.